how I should wear this for official functions. So this is an official function.
Where is the cup?
Cup? No. Let me introduce Matthew Stone, who got his PhD from University of Pennsylvania and spent some time there, and since then has been at Rutgers. And I'm also giving you to strengthen your presentation. Matthew Stone.
So thanks, everybody. Start pacing. So this is a really exciting opportunity for me, but also a really challenging one. I'm going to be presenting some work that's ongoing and that may not look very big. In fact, it may look like stuff that you've seen before in some ways. I actually hope that's true because I'm really here as an advocate for semantics and meaning as a part of the agenda for computational linguistics and natural language processing. And what I'd like to do is argue that once you understand how to talk about meaning and how to look for meaning in spoken language interaction, then you can actually go a lot deeper with the kinds of techniques that perhaps you already are familiar with. So that's the agenda that I'd like to start out with. Okay. So what I'll just do is talk about meaning a little bit and talk about the work that I've done. And then I'll show a demo. And then I'll try to take you through the demo to try to convince you that this is an agent that does something interestingly new with meaning, and it's something that you could all start incorporating in the work that you do. So that's the plan. Okay. So meaning is something that characterizes human interaction all the time. And you're always ready to attribute meaning to people that you're interacting with. Even if you see a little kid and the kid says something like more, right? You know that that's meaningful, that that kid is tuned into a real distinction in the world that matters to her, something that she wants in this case. And she's collaborating with you. She has a real commitment to get you to reach an agreement. And so you'll see that in her pleasure if she gets more, and perhaps her displeasure if she doesn't. And this kind of meaning is something that we all use to coordinate our interactions, and it's what we hope that interactive systems will achieve. But what's apparent, even from the simple example, is that meaning is not just a level of representation or a module in a system. Meaningfulness involves a rich combination of capabilities. It reflects your perceptual abilities to be able to lock onto a distinction in the world that you care about. Linguistic knowledge to be able to convey that distinction to another person. Rational decision making to figure out how to get that message across using the resources available. And social relationships to be able to pursue your meaning, to reach agreement and discuss the consequences. Meaning, in this sense, is really a problem for design in interactive systems. It's a problem about building representations throughout the system and orchestrating the use of those representations so you get a coherent end-to-end effect, the effect of being able to get your message across. So it's very difficult to describe this, and the work that I'm undertaking is one in a long strand of research that tries to specify these capabilities more precisely. What is special about meaningful interactions? What really has to happen? And how exactly do we translate these intuitions and observations we have about effective interactions face-to-face, one person to another, in designing artificial intelligence agents that can display the same kinds of meaningfulness? So this is kind of the framework for the research that I'm talking about. what I'd like to do today is take you through some of the developments in linguistics, philosophy, and psychology that I draw on in refining our intuitions about meaning in face-to-face interaction, and try to distill that into a design, into something that we can implement and test. Then I'll show you a proof of concept implementation of some of the principles that come out of this, and describe some of the lessons learned from the experience. What I had to work through in order to build the system, and what, having built the system, I see as some of the big challenges, some of the gaps left open by the work that I've done so far. Okay. So the setting for this is the simplest kind of interactive conversational scenario that I could think of. It's a collaborative reference game with two interlocutors, one of them called the director and one of them called a matcher. They're in a room, on opposite sides of a partition, and they each have an identical pile of cards, visual elements. Although the cards are the same, they have the same things, the arrangement is different. So the director's cards are in order, and the matcher's cards are just in an amorphous pile. And what the director has to do is to identify the elements, pick the things one after another, so that the matcher can reconstruct the arrangement, so get the cards into the same order. So all you have to do is describe these objects one after another and agree on them. So this is a game that's been studied a lot in human-human conversation in an influential series of experiments by Herb Clark and his students and colleagues. And it illustrates some of the collaborative features of dialogue, that interlocutors work together to make sure that they understand the descriptions that have been given so far. A speaker will try to present alternative descriptions if one doesn't work. A listener will show whether they understand and perhaps suggest alternative descriptions themselves, so that you are able to identify objects satisfactorily and make sure that you maintain mutual understanding as you carry out this interactive dialogue. So perhaps maybe what I should do now is just show you this little interface that I built with my students in a group over the last year that plays this game. It's a very small system. It's something that a lab full of people, linguists and philosophers and just a couple of computer scientists put together in the time frame of a couple of semesters. What I'm interested in doing is talking about the system rather than saying how great it is, because sort of explaining how it works is a way of explaining what meaning is and how to achieve meaning in interactions. So here's the situation. You'll have a pile of objects on the left, and you'll have to arrange them on the right, one after the other. And I can set the system up to play either role. I'll have the system act as director first. So what will happen is it will gradually, incrementally accumulate properties in something like the way that happens in interactive conversations. And it's sort of waiting for you to participate.
Agent means director.
Agent is the agent in this case. So it can play either role. So I set it to be the director in this case. So it's describing this object here. And it has this one in mind. So you can move it and sort of continue. And as you go along, you could, like in these interactive experiments, you can ask it questions to...
And the person who receives information knows there are only these 4 possibilities.
Right, knows that they're in this very constrained situation, knows what the task is, And what we'll see is that part of the research here is to connect the language directly to that specialized task knowledge without having to build a specialized grammar for it. So you can say, is it solid? Asking a question in this case to know what's going on. And this will, we can take a little bit of initiative here, get the answer, and so in that case we know it's this one, and so forth. So I'll put this aside for a second and go back to the slideshow. Okay. All right. So what you have to do to build an implementation like this is formalize the task that's going on, model the domain that people are actually working in. Then understand how each utterance makes a contribution to this ongoing task. And so that you can combine the information that you get in utterances that you hear and plan utterances that you can add so that you can make and track progress on this ongoing task. To do that underlying activity, you need to bridge that with the meaningful language that you see, which means that you need to design a natural language generation system that's going to make moves in this collaboration. You need natural language generation and understanding to function symmetrically so that the understanding system recognizes task moves. And you need to keep the representations that the system uses in track so that you can follow up the stuff that you say with if someone asks a clarification and respond to these changes of initiative so that you can negotiate this ongoing task no matter how the language use contributes to it. So in some sense, this is the kind of challenge or what I was interested in putting together this kind of system. So what I really want to get to, though, out of this is not just the framework, but some of the concrete things that I learned working on this, some of the things that were surprising. So although I'd worked for a long time on natural language generation systems that build these kinds of intention-based representations and work toward presenting task moves, I found that when I tried to put it into an end-to-end system like this, it didn't wind up working the way that I was expecting. So the way that the semantics interfaced with the task was not what we wanted, not what we had when we set out. In particular, where typical systems assume that an utterance is going to specify a task move, in our system we had to have them describe moves, so use a little bit more inference so that you could have domain-independent semantics. One of the other things that we found, and I'll show all of these things in more detail, that is that the state of an interaction is ambiguous because when you really are doing a collaboration and when you're really acting together face-to-face, sometimes you take actions that your collaborators can't see. And the fact that you have these tacit actions, that the state of the task may not be something that your partner knows about, means that the design of natural language understanding and generation has to change to reflect that. So context is not just an input to generation like I thought it would be. And a related point is that as a natural language generation system researcher, I'd expected reference to just be part of generation. But of course, if two people are working together on reference, you can't leave reference to just one module in the system. Reference is a joint task, and there are going to be consequences for reference in generation, but also consequences in the underlying task model and consequences in understanding as well. So the way that generation fits into this system is not the way I was expecting, despite having thought that I was working on generation for dialogue for a long time. And so that's one of the reasons to do a proof of concept like this, that it gives you some insights into the system architecture and design that you wouldn't necessarily have working just on one module at a time. I also want to give you a flavor for some of the stuff that this can't do, some of the weaknesses that we're still working on, that sort of come out of this experience. So one thing is that we need to be clearer about where the content of the representations in the system comes from. That's a very kind of abstract goal, but what it comes down to is that if you want to say that you're designing a system to be meaningful, it turns out that I don't know enough about how to narrate the representations and computations in the system in order to make fine-grained design decisions on the basis of my intuitions about the kind of interactions that I want to achieve. And so there's this kind of philosophical work to be done to be able to design these systems more intuitively. And one of the other things is that this system actually has a really weak notion of intentions, much weaker than I want it to have. I want it to be much clearer about following through. I want it to be able to know whether the outcomes of a conversation is consistent or inconsistent with the commitments that it's made. And this is a much more far-reaching enterprise than I thought it would be going into the task. There's a lot more that a system has to do to really, to start kicking and screaming, if you like, when things don't go according to plan. And this is, I think, one of the important kind of system building issues for meaningfulness. All right, so that's kind of an overview of this work, and it leaves us lots of stuff to talk about. What I'd like to do is kind of take you now back into the implementation a little bit and show you a little bit under the hood what's happening in it. The key thing that I want to get across is what the kind of task model is in this system. The idea that what the task model, and actually I can, it might be easier to just bring it back up. Okay. So it's got a little thing, and you can open its brain. State. Okay. So what it's doing at any point in this task is keeping track of the remaining reference in the objects that haven't been assigned to their places. And at any point, it's got a particular target. There's a particular candidate for the object that comes next. And what you're doing is accumulating a set of constraints on that object until you can identify it. So this actually has kept the history of the constraint the constraints that it posted on the successive objects. So the first target, that's this target T1 here, hopefully that you can see, was that square light brown solid object. So what happened over the course of those utterances, we can see this online in a second, is that you added the constraint that it was a square, added the constraint that it was light brown, added the constraint that it was solid, and then at that point you'd included enough information to represent this, to identify the object. And that, at that point, what I did was click on that object, move it into place. One of the things that's different about this system, as opposed to other models of collaborative reference like Heeman and Hurst's, is that we've actually gone and made a substantive open-ended task model where there's an underlying collaborative activity of placing constraints on objects and using those constraints to identify something. And this underlying activity is separate from language. So there's no syntactic structure associated with this description. It's just it's a record of the abstract problem-solving state that the interlocutors have developed. And what this means is that this is a kind of more general kind of AI type of model. It's something where you could slot the same kind of linguistic processing into lots of other kinds of tasks. Right. So what's happened so far, I've paused the agent, I think. So it's represented this square figure, this second set of constraints, the square figure object and solid figure object. But I think, I understand correctly, it hasn't, I've paused the agent. Yeah, I paused the agent before it actually recognized the move that I make. So if I turn on its brain again, it sort of sees the action that I just did and updates the state of the task, in this case, recognizing that, we've moved that object into place, and we can now move on to the next thing. And let me actually see what happened. And in fact, what has happened is that this agent, the agent has then decided to make its response to say this one's circular. So it's now we can see it's going to describe the blue thing. And it's updated the state of the task in the way that you'd expect from that, which is that we've got a new target in a new constraint network with a new property about it. And so we're just playing the game again. Yep.
So what happens if you move the square instead of...
So this is exactly the kind of thing that is one of the flaws of the implementation, which is that it's not as committed to its interpretations as it should be. So in particular, it just sort of ignores anything that it doesn't understand. And in this case, since it doesn't understand why you would move a square instead of a circle at this point, it ignores it. That's not meaningful. Right? So, but it turns out to be a hard problem for plan recognition to try to figure out why someone would make a mistake rather than, So it's one thing to know how to keep track of a interaction that's going according to plan or according to expectations. But when something goes wrong, you have to try to figure out what mistake underlyingly happened and how to respond to it and correct it. So that's something that we're... Okay.
So you mean it would recognize that this is not the one I meant, but it will not know that you confused square with circular?
Right, for example. Right. That's so yeah. So that's the underlying collaborative activity. So moves in this game add constraints. So the question now is, how do you understand language in a general way as making moves in a task like this? And how do you take advantage of typical representations from computational linguistics in order to, and how do you describe those representations in order to show, in order to get this kind of meaningful language use? To the talk. So this is where I give you a little tour of the cognitive science of meaning. What the kind of meaning that I'm talking about here is interpretation. It's the specific meaning that a speaker conveys with an utterance and the specific meaning that a hearer recognizes. So this is what the philosopher Grice called speaker meaning, as opposed to linguistic meaning. It's the content that comes with a particular utterance. And what we're interested in doing is building an implementation that works with interpretations in a principled way. And that means engaging with classic AI issues. How are these interpretations represented? And what kind of reasoning governs them? How should we be working with them? Okay. So let me just visualize what's happening. One agent starts out with a message to get across. In this case, this representation R is going to be some move in this domain task that we have. Something like adding a constraint on the current target, or choosing a target, or identifying a target and moving it into position. What happens next is that the agent plans and utters a suitable expression. And what you'd like to happen is that the recipient is going to construct a corresponding message, some other mental representation, where somehow these representations have the same content, so that whatever interpretation the speaker wanted to get across, the hearer gets. Explaining communication is about explaining how this is possible, in the physical world, with the kinds of sort of information processing that can be actually realized. Okay. So what we need to do is talk more generally about what kind of mental representations and mental contents are available to agents in situations like this, and how they can connect those representations to knowledge of language. And sort of the reason why to belabor such an obvious point is that, again, it doesn't work the way I thought it would. In particular, I was trained as a semanticist to think about this in terms of two separate problems. A problem of ascribing mental content, sort of giving meanings to representations, and then a problem of characterizing semantic knowledge, some kind of a special case of that where you could somehow translate from an internal representation into words. And these answers were going to be very separate and very simple. In particular, what you see embodied in lots and lots of AI research, from McCarthy and Hayes all the way up to Psych and similar kinds of developments, is the idea that mental content comes from being able to do the right kind of stuff, being clued in about the world. So it might mean having the right theory of a concept, or being able to draw the right kinds of conclusions, or being able to take the right kind of actions. So it's a kind of observational view of mental content that associates it with the inferences or cognitive abilities that you can do. So just to caricaturize this view, your representation C, some symbol that you have in your big semantic network, right, means cake, because the things that you think and do using that node in your network are exactly suitable for cakes. So the best interpretation that we can give to this concept is that it means cake. The other half, so that's mental content. It's just being able to, however we program it up, as long as the system does the right stuff, it'll mean what we think it means. And then semantics is just going to be some generic social facts that describe the information in sentences, and that you can use like any other facts about the world. In this case, to encode information that's available to you into the appropriate kinds of words. So it's a social fact that a latte at Starbucks costs $2.55. So it's this arbitrary thing. It's true. It's instituted, but it's out there in the world. There's a sign over the counter that fixes that information. And in much the same way, the idea is it's a fact about English that the word cake means cake, that kind of food. Right? So in much the same way that when you go to Starbucks, you can calculate how much you need to pay for your exorbitantly priced beverages, when you go to talk to someone, you can calculate what you need to say by using these generic social facts. So, and this is the kind of picture that's embodied in the kinds of truth theoretic or sometimes model theoretic semantics that characterized linguistics and philosophy from the mid-60s until maybe 10 to 15 years ago. So we're just going from syntax to truth conditions. We're not worrying about the real-world content of stuff. We'll just say life means life prime. And we won't think about mental representation or the issues of mental representation at all, because we're just characterizing general social facts, things that are true of English in general. So this is a picture that's associated with Quine and Davidson and Montague, for that matter. You can't, it's a great picture, but you can't build systems like the one that I showed using this picture. And you probably don't want to. There are a couple of things that go wrong. So one thing is that actually it seems like mental content doesn't so much come from being clued in, being able to think the right thoughts and do the right things, as much as being locked in, as having the right kinds of relationships actively maintained between you and your representations and the things in the world that they really represent. So this is a sort of seminal insight of Kripke in Naming and Necessity, or Putnam in The Meaning of Meaning. So I'm not going to believe, so here's Kripke's example. Richard Feynman. When we all think of him, the idea is that we're related to him. That is, we're participating in a big social network where that name and its referent, that physicist, have been passed among us. And we're working together collectively as a community to make sure that when we use that name, Richard Feynman, we're really thinking of that guy. It doesn't matter whether any of us could distinguish a Richard Feynman from other people. If all you know is that he's a famous physicist, you might not be able to tell him apart from Murray Gell-Mann. But nevertheless, because you're working as a speaker of English, as part of the social network to keep the reference on track, when you say Richard Feynman, it still means Richard Feynman, that guy, even though you don't know enough to actually lock in. So it's not about what you know, it's about how you're connected to your community and the kind of relationships of causality and intentionality that hold the community together. Hilary Putnam gives a similar example involving elms and beech trees, which he embarrassingly admits he can't tell apart. But nevertheless, when he thinks of elm trees, he means elm trees. Yeah?
So I'm wondering if this is a paraphrase of what you're saying, that when you and I talk about Richard Feynman, what does it mean for us to be talking about the same guy? Does it mean that if I tell you a fact about Richard Feynman, or you tell me a fact about Richard Feynman, we're both associating that fact with a particular node? And then why is that node any more than just the string Richard Feynman?
Well, this is, right. So,
it seems like we're back to Richard Feynman prime if we talk about things that way.
right. But what it shows is, it underscores that meaning is something that you're going to have to design into the system. You're not going to be able to look just at the, look at the internal representations and see Richard Feynman there, physicist, and know that just because of that it means Richard Feynman. What it means is that if you want to build a system, and you want to say that when it says Richard Feynman, it means Richard Feynman. It means what you're going to have to do is not, you're going to have the right representations, but more important than that, you're going to have the right kind of connections. So you're going to have to look outside the system to its perceptual abilities, its abilities to relate to its users, and make sure that its behavior is consistent with those, maintaining those relationships, preserving that referential continuity. And sort of the related point is that, to put the flip side, the inference is not enough. That even if you know the idea, even if water on Earth is indistinguishable from the mysterious chemical XYZ on twin Earth, and it would be impossible in principle for people like us to tell the difference between them. Nevertheless, we think that our word water in English means water, that stuff that we really have, because what's important is the connections that we have, the relationship that we maintain as a community, rather than the inferences we draw as individuals. Yeah.
I would think that one problem is that if you give me the information that Richard Feynman is interested in breaking locks,
Right.
I may have this, but I may also feel wrongly that he is a juggler, like Shannon. And it's still Richard Feynman, even though I have the wrong information. So it's not,
Right.
it's not a complex that has to be identical.
Right.
So I don't know what needs to be identical for it still to be Richard Feynman, even though I have all sorts of misinformation about him.
Right, and that's an important, that's an actual, in some sense that's an advantage of this, in the sense that, if you're a philosopher at least, one of the things that philosophers like to know is that they can disagree with each other. And nothing worries philosophers more than the prospect that their disputes are just terminological. And in some sense, the fact that you can be locked in to the same person, Richard Feynman, means that you can have these substantive disagreements about whether he's a juggler or a lock breaker. So, and this is why in our system, we come away from it thinking, as I mentioned earlier, that we need to be more precise in how we narrate the content of its representations, because we do have to stand outside the system and look at the kinds of abilities that it has to perceive and relate to its audience when we assess its representations. And so that's really open. Do you want to ask something, Rich?
Yeah, I just, you seem to be implying that you can get away from people's beliefs about what words denote by, insisting that they denote whatever they denote by some common consensual agreement, and I don't see how that's possible, given that people can be misinformed about. I mean, the parallel to the Putnam's elm example is, people may well believe that the buckeye and the American horse chestnut denote two different trees, where in fact they actually denote the same thing. So, but it'd be perfectly possible to have a belief that they're two different things. And so I don't see how you can get away from people's own sort of internal, or maybe you're not implying that, that's what you seem to be implying.
Right. What I'm trying to do is draw a distinction, I guess, between two positions in philosophy that are traditionally called internalist and externalist. Internalist is this view that you're assigning, interpreting the meanings of representations based on the kind of subjective inference that you support. And the externalist view is that you assign content based on the real relationship somehow that you have between the symbols and their reference. What you're pointing out is that an externalist semantics is only a very, very indirect guide to designing a system, because in some sense it doesn't guarantee anything sensible about the system's behavior, right? But and so that would be a worry. It would be a worry that, you know, it would seem that meaning doesn't give you any guide if, you know, if, like you say, you know, you can be confused about anything, but still you say you still are fine with attributing meaning to the system. But I think what you'll find is that when you look end to end at the system, there are a lot of strong constraints coming in there that are very useful. And that's perhaps the second point that I want to make. Because once you start giving this kind of content, you actually have to think very differently about how language works, and you have to take a very substantive, collaborative view of language use. And the key point here is that the meaning of mental states is going to be relating a subject to its environment, because those are the relationships that determine reference. So if we want to build a system that has the same content, that understands what you say, it's actually going to be involved to get that to work. So the idea is that what this agent really has is its task move is a domain-specific representation that in some sense is private, in that the causal connections that determine that content are sort of between it and its environment. So it'll have something like, the next action in my current plan is the transfer physical control routine of my partner to me of that object there, all kind of in an indexical representation that relates you to your environment. And what you're going to have to do is translate this out into some shared terms that this agent will then reinterpret in terms of its own private representations. That, in this case, I've given them all different names to kind of underscore that. So it's going to have its own way of doing that action. It's going to have its own index for that object. And it's, of course, going to flip its representations of who's, you know, you are you and I'm me. Right? So what this means is that your language use is going to contrast this domain-specific internal representations, which is private, formulated in terms of precise domain-specific concepts, indexical reference, and this kind of referential content.
So does indexical reference just mean that things are related by some index function, or is it a broader technical term?
It's a technical term. I don't know if it's broader. It means that it's just so it means that the content is relational. Sorry.
There's a relation between things in the content
the
content representation and
it means that
domain.
it means that the things are the symbols that the agent is manipulating underlyingly are things like here and now and me and things that have a kind of first-person character in some sense. I think that's right. Well, anyway, as soon as you have this kind of, your mental representations have this first-person character, then you have to have a collaborative view of language use. You have to be thinking of the knowledge of language that you have as constraining, but not determining speaker meaning. And you have to have a process of constraint satisfaction that's going to try to figure out, in some sense, what someone could have meant, and in your own terms when you interpret them. So let me just give you a kind of picture of, this kind of collaborative inference, and just to underscore that actually this is some kind of generic social knowledge that you're using in dialogue. We're understanding people, understanding why they're doing what they're doing, trying to get into their heads and think about what kind of content and what kind of representations could explain the choices that they make and the things that they're doing. So in this case, you see a robot wheeling drinks towards a door. And in some sense, what you're doing when you understand that, you can't help but think, gee, there must be a good party on the other side of that door. And in some sense, what you're doing is really attributing a really complex mental state to this robot. You're saying it's wheeling to the door because it plans to go through the door and deliver drinks. And so it has the goal of, it thinks that there's a party on the other side of the door, and it wants it to be a good party, right? So you're altogether taking the action and linking it to the situation and the goals and interpreting it as a complex. The idea of the collaborative language use is that you're doing exactly the same thing when someone says something like, pass the cake mix to you. Behind it, you see a commitment that links the action that they've done. In this case, saying, pass the cake mix, making that utterance. 2, facts about the context, like the availability of reference in the environment that you and your interlocutor are locked onto. And goals, moves that would contribute to the task that's currently at play, represented in the domain-specific way that you're locked onto it in the context. So in this case, getting that cake mix for use in cooking. So what's significant about this is not only does it help you to bridge between stuff that you see and sort of the underlying representations in agents' heads, but it allows you to respond. It enables you to collaborate. So what you do to help this robot along engages not just with the actions that you see it doing, but with the commitments that you infer that it has underlyingly. So you can think something like, hey, I'll be helpful and open the door. That reflects your estimate that the agent is not just wheeling the drinks in the direction of the door, but plans to go through it. And what's interesting is that you're responsible on a team, not just for making sure that things go easier when things go right, but also for pointing out flaws in the plan and making sure that the relevant information for your collaboration is shared among all the participants in the interaction. The same goes for language use. So when you see that someone wants some information and expects you to have that information, you can play your part by providing the information. But it's just as collaborative and it's just as consistent with the obligations that you have to help your teammates to point out that the plan that they have has a flaw. Right. The final point is that what you do for your part in a collaboration has to be presented in a public way. It has to be you can't just contribute to the task, you have to contribute to the task recognizably in a way that the outcome and plan that you're acting under becomes shared. So if you want to help this robot through the door, you could actually sneak around and open the door unnoticed. That should make the robot's life easier, right? Because now it doesn't have to open the door. Except that if it doesn't know, it'll go through all the work of trying to open the door, and you actually might get in its way. So this is something that, again, any agent that participates in a collaboration has to do. It has to act recognizably. And this is in some sense, the main metaphor that I used in my work in natural language generation, to see language use as collaborative. so that you can say things in ways that aren't recognizable, but by eventually elaborating your description, doing something a little bit extra, you can make sure not just that, you can make sure that you're making a contribution to the task that can be recognized. So I've presented a lot of stuff and sort of a lot of abstract ideas, but what it boils down to is a kind of central place for representations of intentions in agent models like the one that I showed you for connecting the task and the linguistic forms that you produce or observe. An intention is just a commitment that an agent will use an action with a particular rationale, making explicit the assumed circumstances in which the agent will act, the causal generalizations that apply, the planned action to be undertaken. And together, that background is enough to predict some outcomes, positive outcomes that the agent expects. And that these representations serve as a fundamental infrastructure for, as the output of understanding, as a kind of substrate for deliberation, for deciding what to do next for your collaboration, and for refining them through processes of generation or production or action in order to make a recognizable contribution to your ongoing task. Okay. Yeah. So let me show you some intentions and sort of how this is implemented in here. We can start with the intention generator, I guess, because let me pick this one. All right. So this is a tree that represents the search space for planning and utterance in the collaborative mode that I just showed. I just hinted at with that give me example. So this is the planning process that led to the thing describing one of the earlier targets as it's light brown. And what it's actually doing is searching directly over the grammar to find a lexicalized derivation of an utterance that can contribute the task move that it's looking for in a recognizable way. The task move that it's looking for in this case is to assert that the target under discussion has a particular color property. And I guess what's interesting about it is that you can see here the substantive inference that the system is making in order to make sure that its utterances are recognizable. So it starts off by trying to describe the object as brown. So here's an abstract. So here's the communicative intention. The first thing to notice just right off the bat is that there are two possible interpretations of this, because there are two different colors of brown in the display. And so it might either be light brown or dark brown, and the utterance doesn't specify it. So this utterance is not going to be enough to identify the contribution that the system wants to make at this point. So what happens in response is that the system adds the modifier light to describe the color further, and what that does is rule out the dark brown interpretation. So what you get here is something is this funny kind of representation. And what I want to do, just to kind of wrap up, is to narrate this representation as an intention, and then simultaneously to narrate this representation as a typical data structure for computational linguistics. So what you have here is a representation of an action. That's the syntax tree in the upper right. I can make it bigger, but it's just a tree. You've seen this stuff probably all the time. What happens is that the linguistic meaning is now expressed in terms of a set of constraints on the context and a set of moves that can be made. And operationally, what you can think of this rule as saying is this is the causal knowledge. This is the knowledge of language that it embodies the theory of action that you're using to coordinate using this action in this context. So what it says is, if you can find a move in the current task, and if you can find a color, brown, that's brown and light, and if you can find a way of updating the context to make something salient, then using the sentence, it's light brown, will do two things. It will make a task move saying that an object has that color, and it will change the salience in the conversation so that the object that you've just described, it has that centered status. So that's the rules. The important thing about the rules is the color coding up there. And the important thing about the color coding is that this green stuff, the linguistic knowledge, is just constraints that you're matching against the context. And the assertions, the task moves that you're making, is entirely in brown, in that reddish color. And what that means is that it's entirely domain specific. All of the content that you've gotten from this utterance, you've got all of the work that it does in the context, you've calculated by matching general constraints against the context. So you can, in some sense, you can use this to say anything. And of course, that's one of the challenge of this semantics and pragmatics interface. So one of the things that, this is the point I made earlier, that you have to describe task moves rather than specifying them. So what we hope is that this kind of representation may make it easier to do kind of to draw on domain independent resources for semantics and pragmatics while still calculating useful domain specific interpretations.
Yeah, so I think this question is addressing Richard's point from before. Would you object to taking this a step further, and instead of assuming that brown P exists in the language, that you have something like named predicate of capital Brown, comma, quotes Brown?
I wouldn't be unhappy with that.
Okay. All right. So my Brown doesn't have to be the same as your Brown. All that we're asserting is you want to invoke my whatever concept I call Brown. And if we disagree on that, then there will be a failure of communication, but I'll still respond in terms of what I think Brown means.
It sounds like you're letting symmetry go, and I wouldn't like to let symmetry go. But yes, there's certainly a lot of possibility for, let's say, ad hoc conventions in the way that you map language to the domain.
I think the picture that you put together in my brain over the last half hour is that each of us has some network of concepts. So, expressed as a database of prologue facts or a graph, or maybe you have special nodes to deal with quantification, whatever. And we each have those, and when we talk, each of us is trying to tickle the graph in the other person's brain. But the only points of contact in the graph is that I have a node called quotes round, and you have a node called quotes round. And I can't actually tickle the unnamed nodes. All I can do is tickle the nodes that have that correspond to lexemes. Actually, I shouldn't even say lexemes. I should say bits of phonology. And I try to use those to grab onto those in order to shake the rest of your network.
I don't disagree with that, but the fact that you're talking about tickling.
It's not appropriate to this forum.
It might very well be appropriate to this forum, but it's actually. I don't know. In my own experience, tickling is not collaborative. Right. So the point is that like tickling suggests that all you have to do is lie back and laugh, and you're not just right. Yeah, I know that's right.
But can we take the view that in fact the objects have been looked at by the two participants independently? And what happens to me is that I have disputes with people whether something is blue or green. And when he says, or when my friend says, you know, move the blue object, I say, you mean the green one? And then we're going to have a dispute with, you know, whether we mean the same thing. And you really have to have a kind of a resolution of something like that when I have things represented.
Right. So we're beginning to do that.
I mean, it's not all blue that I think is green. I mean,
no, yeah, no, there's
borderline.
There's substantive work, and
But you also have weird perceptual systems. So my husband has color blindness. So when we discuss color, he just doesn't have the ability to perceive some of the colors that we're discussing. He just cannot see it. So we could have arguments and never resolve it.
Well, you'll converge on that. You mean that square, right?
Right, eventually. So, but you would use other descriptors then, right?
Actually, I mean, even if you can take it beyond the case of the disagreement over the color, because at least in that case you're talking about some color and you're disagreeing on the shade. But sometimes, I mean, from the human interaction experience, when you say something with a collaborative intention, maybe the way you said it actually will tickle, and I mean tickle in an uncollaborative way, something else in the mind of the other side, you know. So there's nothing here to model that either, right? I mean, that you could actually get a totally different impression of what the request is, or start thinking about something totally different. And then that, I think, is going to be a big problem, because there's just a huge space of possible interpretations.
yeah. So
Well, that's a good answer. All right.
I just want to show a couple of other things quickly about the program. So I just want to convince you that these data structures that I've been showing, that I've argued represent intentions, are being manipulated sort of systematically by all the modules in the system. So this is a snapshot from the parser, where the parser is actually looking at, is it solid?
This is a question.
This is a question, that's right. So, and this is, so it's asking, what it's actually asking semantically is to play this game that I'm not sure if it's domain specific or particular to language of this yes-no query, where you determine whether or not to make a particular move in the task. Let me, this is right. And so this, in this case, is can you make the task move of adding the constraint that the target is a solid object? Okay. What I just want, so this is this structure now is being calculated in understanding. It's exactly the same kind of structure that I showed before as the output of the generation process. So it's, both of these are fed into a common process of deliberation to update the context in response to actions that you observe. And in fact, you can kind of go into the chart here and sort of see the, you can see entries on individual words already being interpreted, trying to be interpreted, drawing on the constraints, applying the constraints from the grammar to the context and trying to figure out what kinds of moves fit the task. So you can have this kind of constraint satisfaction model, sort of factored right down into the basic operations that the system is working with. So the one other thing I want to show is just to give you a sense of the way that these kinds of representations can inform deliberation. So if I start this over again, it'll basically say the same thing because I've shown you everything it can do just about. This is the last. So after it says it's light brown, it's got this representation of its intention that it can now add to the discourse state, which says that it's trying to use the light brown to represent that particular color. So that representation is available for all the kind of further work of collaboration that you'd like. So in this case, if you say, do you mean tan? It knows that it does. And if you look at the state of the interaction at this point, it actually has a nested constraint, a nested process of collaborative reference. At the outermost, it's identifying this square figure object, and it's, for the moment, pushed the fact that it's calling the square light brown. And at the moment, what it's trying to do is solve this nested collaborative reference task of figuring out what property you're trying to ascribe to it. And it's tried to add the constraint that it's equal to that color, which is the intention that it attributed to you when you said, do you mean tan? So this is just a kind of promissory note that these kinds of representations can be used kind of systematically throughout a kind of collaborative dialogue architecture. So I'll just conclude now. I think what I'd like to do to just kind of go back to some of the kind of take-home messages that I started, and hopefully it's clear by now what I was talking about. So that the kind of designing for meaning, designing to make interactions where you're working to make yourself understood and pursue interaction in order to get your ideas across, means integrating natural language and collaboration very closely together so that you think throughout the design of the dialogue system kind of simultaneously at the function that utterances play in the collaboration and at the linguistic structures and choices that are available to you to pursue that collaboration. exploring this design space is challenging, interesting, and productive because it leads you to, I think, genuine observations about dialogue and that you wouldn't necessarily find without trying to build end-to-end systems and understand how the architecture fits together. It also points to directions for research where you realize that certain capabilities in the system are more difficult and more important, and that you should focus your attention, that way in planning new research, so that you do kind of arrive at some insights, even in this more or less toy system, that you can expect to build on as you kind of scale semantic processing and let's say try to add deeper semantic resources into the toolkit of language technology, because these insights are real constraints both on how we interact with each other and on how we can build interfaces to achieve the kind of meaningful interaction that we take for granted with one another but find so hard to reproduce. Thanks. Brian?
Yeah, so when the system has initiative, it seems like you have many possible utterances that you can use to sort of initiate this, and that, at least in a human, you would expect them to take the most informative step, in some sense, the thing that will best advance whatever the goals are. But it seemed, and perhaps this is this system, but it seemed like that wasn't driving the system initiative here. You say it's square, and there were 3 squares, when in fact you could say it's light brown, and there's only 2 light brown things. And so I'm wondering, and if we knew after many interactions that the other person was colorblind, then maybe square would be the right, that most informative step. And I'm just wondering to what extent that needs to play a role, or
Yeah, I mean, so the best way to identify things to people is an empirical question. I'm really excited about, gathering that information is also pretty challenging. To many people, famously Lynn Walker, the best way to gather that information is to build a system like this and have it talk to people. If we could do that, then we could take a reinforcement learning or game theoretic approach to optimize our interactions based on what works. Until we do that, I hard-coded a heuristic that Robert Dale and Ehud Ryder argue is the simplest effective thing you can do.
So this is this question may have to do with different logical differences, but I think
Okay.
it's related to what everybody else has been asking about. So, I mean, to me, what stands out as a major problem to be solved is the problem of modeling other agents' mental states, and maybe that's something that that didn't come up to me as something that you're really talking much about, although maybe that comes under the rubric of other things you're mentioning. But so, for example, at the end, when you're in the case it's light brown and you say you mean hand, I mean, one part of the problem of to solve what to do when the agent hears do you mean can is to how to answer. But it seems to me that a rational agent that has the ability to model the cognitive states of other agents, the mental states of other agents, would do a lot more, including it would do things that could affect, for example, subsequent utterances and make perhaps substituting tan for light brown on the basis of new information it has about the mental state of the other agent. So is that kind of action something that falls under the rubric you've already described, or is that a whole other dimension you'd have to add on?
So this already models mental state in two ways, I would say. So the first is that it distinguishes systematically between information that's shared and information that's private in all the representations that it has. So I didn't flash it, but so this is the shared view of the task, and one of the aspects that is that when you look at what's common, that you don't know what the intended referent is of these tasks. But in this case, since the agent is the director, when I switch over to the agent's view of the world, the agent actually knows that this is what it's intending to describe at this level, and this is what it's intending to describe at this level. So it is distinguished both in the task and in facts, the facts that it uses, these different perspectives. So there is some idealization that goes on when you just think about a level of shared knowledge that downdates that represents a slice of your own knowledge that you assume that the other person has. So when you look at something like one of these cases where interpretation doesn't go originally to plan, it doesn't try to, there is some additional kind of second guessing that you could try to do about what private information they have that you don't have that could be leading to the particular responses that you get or the particular course of the dialogue that you have. That's obviously important, and we're not modeling it. But you could. I mean, again, much as the way the kind of decision theoretic considerations that Brian was talking about is some sense a dimension that you could learn to tune your decision making within this model. So is that, yeah.
I was wondering if you have, in fact, if both parties have a specification of these squares and objects. I mean,
yeah.
In my mind, this is nowhere 10, right? This is 10.
Right.
And I would not even say that it's light brown. I would say it's rosy.
Yeah.
And
on my laptop, it's light brown.
If the thing says, is it tan?
Mm-hmm.
It's true that if I knew what tan was and I had to examine which is more tan than others, even though none of them are tan,
right.
then I could probably find you mean that
right.
that square. But you don't have any of that in the system, right?
Not in the system,
right.
No.
And it's quite a long time.
Well,
ways, even for such a simple situation.
So we had a preliminary implementation that did vague measurements of length and size using more or less the inference that you talked about that we presented at Coling last summer. It was implemented in Prolog and got too brittle and too slow to demo. But yes, what you really like is to try to coordinate with the other person in a more fine-grained way. Like, if you don't know what the word means, to make hypotheses about what it could have meant to make sense in the task. The representations that we have are powerful enough to do that, but the inference is a little bit more involved. I don't know who's next. I think, are you?
Actually, I had a question about the inference process. Which
Mhm.
It seems like you still need, sorry, not still, it seems like you need a lot of inference rules, which are hand-coded, just about all the specific intentions and the results of actions, which constitute the domain-specific model for the world.
And so you mean, we had to say what it means to add a constraint to a constraint network.
Well,
That,
but also this is the, I guess, but also the task is you're trying to set objects in these scenarios when
yeah.
that this is that kind of collaboration.
So
I mean, above and beyond what fringes.
Right, right. So if you look at the, sort of the long term about how is this going to fit in? So these kind of task models are expensive. On the other hand, the benefits that they offer are pretty substantial. So if you're building a caregiver robot or a virtual child who's a tutoring system for education, these are cases where well, it's important to handcraft the underlying models of the system, in the sense that you want to be pretty sure about what the content and behavior of these systems is. It's also something where the kind of functionality of a tutoring system, depends on having kind of deep information available, or the functionality of a robot assistant depends on it establishing a genuinely assistive relationship with its users. So I think that these kinds of collaborative task models are going to be out there. And I see the language, the challenge for linguistics is how to hook up the utterances flexibly with these task models using domain general linguistic resources. So if you don't buy that, that's fine. But the fact is there are lots of people programming full time by hand, and if it pays off, it happens.
So I'm going to ask you a question about.
Mona had her hand up
sorry.
for a long time. And,
Sorry.
Mona, go ahead.
Sorry.
Let that be the last question, because,
Sorry.
well, okay.
So really my question was very much related to the
Okay.
previous question
Okay.
about the scalability of this. So it seems to me like there is this closed world type of view on how this would carry on. What would be necessary for this to be scaled up? Would you need something like psych, something, what kind
No,
of...
I don't believe in psych, so it better not need
I'm
it.
wondering what would make this more of a functional as opposed to a proof of concept toy type systems to be
So you need a grammar. We know how to do that. You need a reasonable task. My feeling is, well, that's not a linguistic problem, but this is just these techniques are designed so that whatever big program you come up with will be able to hook up with this. And then presumably you need to be able to have some optimization techniques to let's say tune the disambiguation of the system in ways that are natural. I think that, so the way to get that realistically is to kind of bootstrap the system so that it's capable of having robust enough kind of clarification dialogues in cases where it doesn't understand or understands incorrectly, that it can develop sort of its own corpus of experience, in some sense annotated in a deep way.
Within that restricted domain.
Within, I mean, I'm extremely skeptical of domain general content. But yeah, so there's work to do, but in many respects I see that as being very continuous with the stuff that's already happening in terms of being able to optimize for preferences, being able to have intuitive, lightweight systems for, collecting data without requiring a lot of hand annotation, and kind of having a good software engineering design so that you're working with reusable resources to the extent that's possible and flexible interfaces to the extent that's possible.
Okay, you want to ask your question
No, that's fine.
in 3 minutes? No, not question, so you get an answer in 3 minutes.
Yeah.
Your system,
Right,
in some sense, is built from looking at sort of adult behavior.
right,
At a particular snapshot in time.
Right.
You might posit that maybe a developmental perspective would give you actually something that would be more adaptive and would ultimately provide you with the ability to project forward in time and have more adaptive systems that would be more domain independent and that type of thing. The issue of coming in at the adult side does seem to me to give you sort of more rigidity than you might have in terms of designing with a developmental perspective. So I guess it's more of a comment than a...
yeah. No, I mean, I see so many places to add learning into this, basically.
Right, but you could
but-
actually start from a much more naive state. Right, so it's not going to give you a wonderful interaction initially, but as long as there was learning, then you could actually eventually converge to things that
Right.
Ryan's talking about.
Okay. I want to remind you that we're starting at 1 o'clock sharp in the afternoon.